Now you ready for a bit more of a challenge? We're next going to consider simplifying radical expressions where the denominator now contains radicals with an index other than 2, or square roots. Now in the problems we looked at prior to this, all the denominators were square roots, and we were interested in multiplying by a square root expression that would produce a perfect square to rationalize the denominator. Now for these examples we'll be looking at, our reasoning will be similar, except we have to think a little more carefully about what we need to multiply by to rationalize the denominator. So for our first example, we have 5 divided by the 6th root of 2. Now, would you agree we would like to multiply by a radical expression involving the 6th root, where the product will produce a power on 2 that's divisible by 6. And we would like that to be the smallest power possible in general. So since we have 2 to the first inside the first radical, would you agree that we would have to multiply then by 2 to the 5th? So multiply the numerator by that as well, 6th root of 2 to the 5th. So we have then in the numerator 5 times the 6th root and 2 to the 5th is 32. And in the denominator we have the 6th root of 2 to the 6th. And very conveniently we know that that will simplify in the denominator to just 2. Numerator still the same, 5 times the 6th root of 32. And we're not able to reduce the fraction any further, so that will be our final answer. Now, did that make sense in terms of how we reasoned? I hope it did, because we'll need to use the same kind of reasoning for problem in part B. Now in part B, can we reduce the fraction that's the radicand? And the answer is no, we can't. So what we'll do next is to rewrite using the quotient property. So we have the 5th root of y squared divided by the 5th root of x to the 3rd. Now take a moment and think about what we would need to multiply by in the denominator to rationalize that denominator. And since the index is 5 here, we would need to multiply by the 5th root of something so that the exponent on x is divisible by 5. And the smallest such power would be then 5. I trust you'll agree. So we need to multiply by the 5th root of, and did you get it? X squared. And the numerator, multiply by the same thing. So we have then in the numerator the 5th root of, I'm going to put the x squared first, so we have the 5th root of x squared, y squared. And in the denominator we have the 5th root of x to the 5th. And so our final answer then will be the 5th root of x squared, y squared, all divided by x. So we've succeeded in rationalizing the denominator. And in the numerator you can see that neither of the powers on x or y are large enough that we can simplify that any further. Alright, are you ready to tackle the last problem now? Now this time we have the index in the denominator being 4. So let's think carefully here about what we would need to multiply by to rationalize. Now again, we would like the product here to be one where the power on the 2 and the x will be divisible by 4. And the smallest such power, of course, will be 4. So on the 2, we have 2 to the first. So we would then need to multiply by 2 to the 3rd power to produce 2 to the 4th. And for the x cubed, all we need is another x. So then we multiply the numerator by this as well. This would be the 4th root of 2 to the cube, 2 to the 3rd, times x. And so this will now be, and let's come down to the next row to finish this up. In the numerator we will have 4x times the 4th root of, and we'll write this as 8x. In the denominator we'll have the 4th root of 2 to the 4th, x to the 4th. So we have 4x times the 4th root of 8x in the numerator. And the denominator, I trust you realize, will simplify to just 2x. And now in this case we can reduce and simplify the fraction further. So the 2 in the denominator will divide into 4 and give us 2. And the x's will cancel completely, so we're left then with 2 times the 4th root of 8x. Now that wasn't too bad, was it?